here, we definitely talk about the factors that affect the resistance of the conductor. The first concept, talking about current electricity. Factors affecting resistance of the conductor. Means what? The first factor, we have said, resistance is the direct proportion to the length of the conductor. Means, as you increase the length of the conductor, there is a gradual increase in resistance of the conductor. But also, resistance of the conductor decreases as you increase the cross-section area. Means what? Resistance of the conductor is in proportion to the cross-section of the area. Now, combining the two factors, resistance is the proportion to the length of the conductor and inverse proportion to the cross-section area. And from here, resistance is equal, removing the proportionality constant. Resistance is equal to K L over A. But this K is proportionality constant. It's called resistivity of the conductor. And therefore we say resistance is equal to resistivity times length over cross-section area. Kwa hii ndo kanuni. Kwamba unapotafutia resistance of the material, lazima kwanza consider resistivity of the material. Kwa hiyo hapa resistivity of the material. Now, in short, resistance of the material is equal to resistivity multiplied by length of the conductor divided by cross-section area. Kwa hiyo ndo kanuni. This resistivity of the material determines the nature of the material. Four factors in which the resistance depends on. The first factor, length of the conductor. The second factor, cross-section area. Third one, temperature of the material. Now the temperature of the conductor, as you increase the temperature of the conductor, also you are increasing the resistance of the conductor. But the last one is called nature of the material. Resistance of the material depends on the nature of the material. And this is very important case. As you can see in the first question, this relies on the nature of the material. If now you have not related the nature of the material, you cannot solve this question. Are you together? Now, from the first question, an iron one has a length of 0.5 meter and a diameter of 1.6 millimeter. Now, what is the resistance of the wire? That is A. B, what will be the current in the wire if it is connected to a 9 volts battery? As however, the most important thing to deal with, you like data. Now you have length of the conductor which is equal to 0.5 meter. Now you have diameter is equal to 1.6 millimeter. Now let us convert this into radius. It is very important for us to deal with the cross-section area. When I talk about the cross-section area is equal to pi r squared, or is equal to pi b squared. Over 4. This is cross-section area. Sasa ni ngumu sana kushughulika na hii hapa. So difficult for us to deal with this one because it involves division. But this time our it was simple. Tuko pamoja jamani? Kwa maana hiyo kama hiyo ndio kesi, maana yake unashughulika na hii hapa cross-section area. Sasa hata kama even if you use this one, haiwezi kaleta tofauti. The same case that you have done. Tunaelewana vizuri? Kwa maana hiyo kesi ya hapa na hapa inafanana, lakini tofauti ni kwamba here diameter, here radius. Now you can convert this one into radius. Diameter into radius kwa tunafanya kwa ngapi? By 2. Ambayo kwa 0.8 millimeter. This is radius. Now the question is, find the resistance of the material. Now the resistance of the material is calculated by taking resistance is equal to resistivity, length of what? Of cross-section area. Now length is there. Length is here. 0.5 meter. Are you together? And also area is not there. So we need to calculate the area. Resistivity now is constant. We're talking about iron. Now resistivity is equal now 9.71 times 10 power negative 8 ohm meter. That is constant. Now, if that is the case now, sasa hii ni resistivity. Let us look for the cross-section area. Amount cross section area is equal to pi r squared, which is equal to 3.14. That is the value of pi. But now radius. Radius is here. Radius is written in terms of millimeter. Now we need to convert into meter. Kwa lazima ibadilishe kwenda kwenye nini? Kwenye meter. Ambapo sasa itakuwa ni 0.8 times 10 power negative 3 times 0.8 times 10 power negative 3. Si ndio hivyo jamani? Kwa maana hiyo, according to the algebraic, to the exponential law, 10 power negative 3, 10 power negative 3. Ambapo itakuwa ni 3.14 times this time this one. Now 0.64. Now times 10 power negative 6. This is a cross section area. Now after calculating the cross section area, you definitely get is equal to 2 times 10 power negative 6 meter squared. This is a cross section area. That is what? After multiplying 0.64 times 3.14 times 10 power negative 6, definitely you find cross section area is equal to 2 times 10 power negative 6 meter squared. That is a cross section area. Kwa tayari tumepata cross section area. Sasa tunauliza resistance. Resistance is equal to resistivity times length over cross section area. Resistivity is equal to 9.71 times 10 power negative 8 times length is equal to 0.5 over now 2 times 10 power negative 6. Sasa utaanza kukatakata. Now here you remain with 10 power negative 2. Now you definitely remain with 9.71 times 0.5 over times 10 power negative 2 over 2. Now which definitely is equal to 0.024 ohm. Now resistance of the conductor is equal to 0.024 ohm. Kwa maana ya kutafuta resistance of the material tunapata hivi. Sasa after we have done resistance of the material, from Ohm's law, V is equal to IR. What tunauliza nini? Current. Now current is equal to V over R. Now voltage is 9 volts over resistance. Now we have got 0.024. Ambapo sasa tutajikuta is equal to 375 ampere. So now current is equal to 375 ampere. Kwa hiyo hapa, what definitely you are required here to find the resistance using the factors affecting the resistance. Ambapo tumetumia sasa kwamba resistance is equal to resistivity length over area. Now length was there, cross section area is equal to pi r squared. Then you calculate, then you substitute the resistivity, which is constant. Definitely you would have get 0. As what we have squared it here, 0.024 means ohm. Baada ya kupata una apply Ohm's law. From Ohm's law is equal to IR. Now I is equal to V over R. Kwa unachukua hapo unagawanya, definitely you get 375 after dividing it. What is the length of a wire of a diameter 0.6 millimeter and resistivity of 1.1 times 10 power negative 60 ohm meter would make a resistor with a resistance of 44. That you have diameter which is equal to 0.6 millimeter. Let us convert it into radius. Radius is equal to 0.3 millimeter. And this millimeter, let us convert into meter. Now it is 0.3 times 10 power negative what? Negative 3 meter. According to exponent, here, it is 3 times 10 power negative what? 4 meter. This is radius. Now, then we have resistivity, which is equal to 1.1 times 10 power negative what? 60 ohm what? Meter. We have resistance, which now is equal to 44 ohm. The question is to find length of the conductor. From the formula, resistance is equal to resistivity length of what? Now let us make L the subject of the formula. Now multiplying by A both sides. Now AR is equal to resistivity over resistivity times L. Now divided by resistivity, divided by resistivity. Now length is equal to area resistance times over resistance. Resistivity. Now substitute what you've been given from the question. Now length is equal now, cross section area, resistance over. But remember, area is equal to pi r squared. Now which is equal to 3.14 times r. R is here. 3 times 10 power negative 4 times 3 times 10 power negative 4. Collecting the right terms. Kwa huyu itakuwa 3.14 times 3 times 3 9 times 10 power negative 8 is equal now to 28.260 times 10 power negative 8. Ambapo unaweza kuirudisha hapa. This is meter square. Now cross section area is equal, we have got cross section area is equal to 28.260 times 10 power negative 8 times resistance. Resistance is what? 44 over resistivity. It is 1.1 times 10 power negative 6. Now this one and this one 10 power negative 2. Is it so? Now this time this one is equal now to 1243.44 over 1.1 times 10 power negative 2. Now it's equal to 113.4 times 10 power negative 2. Ambayo in short, hii hapa maana yake itarudi mara ngapi nyuma? 1 2. Itakuwa is equal to 11.3 meter. Now therefore, the length is equal to 11.3 meter. Now length of the conductor is equal to 11.3 meter. Hiyo ndio umeulizwa hiyo. But the most important thing was how to know. This was all about substituting. Now you know the data that you've been given. Diameter there, you convert into radius if you wish. Then you have resistivity there, resistance there. What you've been asked to find the length of the conductor. Now from here, resistance is equal to resistivity times length over cross section area. Now length is equal to cross section area times resistance over resistivity. Now then, but area you calculate the area, then you get it. Then you substitute what you've been given from the question. Definitely length is equal to cross section area, which is equal to 28.26 times 10 power negative 8. Then times resistance, which is equal to 4 over resistivity, which is equal to 1.1 times 10 power negative 6. Thus, napata hivyo. Simple after calculating. Question number 2. A wire of 2 meter and cross-sectional area of 0.5 millimeter square has a resistance of 2.2 millimeter ohm. Calculate resistivity of the material making up the wire. Data. Length of the wire is 2 meter. Cross-sectional area is equal to what? 0.5 millimeter square. Resistivity of the wire, resistance of the wire is equal to 2.2 ohm. The question is calculate resistivity of the wire. From resistance of the wire is equal to resistivity length over area. Make this as the subject of the formula. Now you multiply by A both times. You get this one. Is equal to resistivity L. Now back by L both times. L. Now remember, resistivity is equal to area times resistance over length of the conductor. This is the formula. Now calculating like resistivity is equal to area times resistance over length of the conductor. Now area, remember you have area. Hapa a case was to convert this millimeter squared into meter. Remember, 1 meter is equal to 1,000 what? Millimeter. This is not a formula that definitely convert this one. You square both sides. Then 1 meter squared is equal to 1 million. A square of 1,000 meter squared. Which now is equal to 10 power 6 meter squared. Now it's just like dividing this 0.5 by 1 million. Now this definitely will become 0.5 times 10 power negative what? 6 meter squared. Now definitely we find 1 meter squared is equal to 10 power 6 millimeter squared. Now if you try this one by 10 power 6, you definitely get this one. Kwa maana yake ni kwamba 0.5 divided by 10 power 6. Hii inapanda huku juu. Now if that is the case, now resistivity is equal to area times resistance over length of the conductor. Now area is equal to 0.5 times 10 power negative 6 times resistance, which is equal to 2.2 over length of the conductor, which is equal to what? To 2. Then by 2, 1. By 2 here, 1.1. Is it so? Now it is 5. Now we have 5. How many decimal are there? 1, 2. 5, 5. Now 1, 2. 0.55 times 10 power 6. This is the ohm meter. But this is not okay. Why is it not okay? Simply because this is according to exponential form. This is not a standard form. Now we need to convert. You bring it back here. Now you get 5.5 times 10 power negative 6 times 10 power negative 1, which now is equal to 5.5 times 10 power negative 7 ohm meter. Now the resistivity of the material is equal to 5.5 times 10 power negative what? 7 ohm meter. Because the most important thing was here. Resistivity of the material is obtained by taking the cross-section area times resistance of the material over length of the material. Now, cross-section area was there. Resistance was there. Then length was there. That is all about substituting everything that has been given from the question. Now, the substitution, that's all about multiplication. A 1.1. Then this time, this one you get 0.55 times 10 power negative 6. Then remember exponents. Now you bring it here. Then it becomes 5.5 times 10 power negative 6 times 10 power negative 1. Then exponential. So, then 10 times, this is 10. It is negative 60, negative 1, negative 7. So this is how we get it. Now the resistivity of the material is given by 5.5 times 10 power negative 7 ohm meter. A wire of length 1.2 meter and a diameter of 0.64 has a resistance of 2.4. Calculate the resistance of a wire of a length 0.8 and a diameter of 0.32 millimeter of the same type. There were 2 wires. Lakini, what interesting between those wires? Same material. Same material means resistivity of the first one. If this is length 1, this is diameter 1, this is radius 1, this is resistance 1. Now, resistivity 1 is equal to resistivity of the second wire, which now we don't know. Resistivity of the first wire is equal to the resistivity of the second wire. Now, resistivity is the same because this wire of the same material. Now, you use the first wire to calculate the resistivity. Now, resistivity is equal to AR over length. Now, area of this wire, if radius is this one, now it is 3.14 times radius, which is equal to 0.32 times 0.32 times now 10 power negative 6. Why 10 power negative 6? Kwa sababu ni mara mbili. Now times resistance of the wire. Resistance of the wire is 2.4 over length of the conductor. Length of the conductor is 1.2. After multiplying that one, you get 0.77. We can approximate 72 times 10 power negative 6 over 1.2. Now, definitely after that one, you will get 0.64, 3, and so forth. Now times 10 power negative what? 6. Now 0.64 times 10 power negative 6. Now bring in this one. Now it will be 6.4 times 10 power negative 7. This is the ohm meter. Now, the resistivity of the material is equal to 6.4 times 10 power negative what? 7 ohm what? Ohm meter. Now, after we have done the resistivity of the material, remember we've been told even the second wire of the same what? Material. Means the resistivity of the first wire is equal to the resistivity of the second wire. Now, resistance of the wire is equal to resistivity times length of what? Of a cross-section area. Now, resistivity of the wire, the first wire, now the second wire, length is equal to 0.8. Resistivity is equal to this one. Now it is 60 times 6.4 times 10 power negative 7 times length of the second wire, 0.8. 0.8 over area, cross-section area. Remember the diameter. Diameter 2 is equal to 0.32. Now converting to radius. Converting it into a radius, we divide it by 2. Now we get 0.16 times radius is equal now times 10 power negative 3 meter. Now that is radius. Now we have 0 cos area is equal to pi r squared. Now we have 3.14 times r, which is equal to 0.16 times 0.16. By this is 10 negative what? Negative 3. Now there are 2 of them. Then 10 power negative what? 6. Now by 6 here, by 6 here. 10 power 60, power negative 60, 10 power negative 6. Now you have 10 power negative 1. Now after multiplying this one, you get 5.12 times 10 power negative 1 over 0.08. Now when you divide by this one, you get 64 times 10 power negative 1, which now is equal to 6.44 resistance. Now the resistance of the second wire is equal to 6.4 ohm. For hapa, the most important thing here was all about talking about the resistivity of the material. Kwa sababu amekwambia the wire of the same material, mean the resistivity of the material is the same. There is no difference in the resistivity of the material. The diagram below shows an electric circuit in here. This is voltage across the battery. Now, resistance 1 is equal to 4 ohm, 2, 5 ohm, 3, 6 ohm. VB, voltage across the battery, that is 9 volts. Question. What is the total resistance of the circuit? Resistors are connected in series. Now, A, total resistance is equal to R1 plus R2 plus R3. R1 is equal to 4. Then R2 is equal to 5. Then R3 is equal to 6. Now is equal to 9 times we get 15 ohm. Now total resistance is equal to 15. B. What is the current flowing in the circuit? The current flowing in the circuit from Ohm's law, V is equal to IR. Now I is equal to V over R. But the resistance that we talk now, because we are talking about the current flowing through the circuits. And since these resistors are in series, the current here, the current at here, the current at here, the current is the same at any points, at all points. Katika kila point current ni moja. Current at point A, the same as the current at point R1, at R2, at R3, at this cone, the current is the same. Now, calculating the current flowing through the circuit, we take the voltage across the battery, then we divide by the total resistance. Now, voltage is equal to what? 9 volt over resistor, total resistance, which is equal to what? Is equal to 0.1, 0.6. Now this is ampere. Now the current flowing through the circuit is equal to 0.6 ampere. The other question, what is the potential drop across each resistor? Kwenye resistor hapo kutakuwa na potential difference ngapi? Kwenye resistor hii hapo kutakuwa na potential difference ngapi? Kwenye resistor hii hapo kutakuwa na potential difference ngapi? if resistors are connected in series, we say the potential difference is different. What is common is the current, but the potential difference is not common. But what is common is what? Current. Now, this is in C. For R1 is equal to 4 ohm. The current is the same, 0.6 ampere. Now, from Ohm's law, V is equal to IR. Now, I is equal to 0.6 times 4. Now, which is equal to 2.4 volt. Now, for R, 2 is equal to 5 ohm. Now, VI is the same. Concept hii usisahau kwamba current ni moja ile ile. Because they are connected in series, we say the current is the same at all points. For now, also here, V is equal to IR. Now, I is equal to 0.6 times 5. Now is equal to 3 volt. Now, for R3 is equal to 6 ohm. Means what? Now, I is the same, which is equal to 0.6 ampere. Now, voltage is equal to IR. Now, I is equal to 0.6 and R is equal to 6. Now, it's equal to 3.6 volt. What is interesting? If you take this one plus this one plus this one, an answer is equal to voltage across the base. And that's why we say the sum of the voltage around the circuit must be equal to the sum, must be equal to the voltage across the battery. Now, when you take VE is equal to 3.6 plus 2.4 plus 3, which now is equal to 9 volt. The voltage at point R1 we have seen is equal to 2.4 volt. Voltage at point R2 we have seen it is what? It is what? 3 volt. R3 3.6 volt. If now you sum them, the voltage across the circuit, the sum of the voltage across the circuit must be equal to the voltage across the battery. And that's why this plus this one plus this one equal to 9 volt. What is the potential? What is the electric potential at point A? Listen to this point very carefully. Electric potential at point A. Have you seen this point A? It is right here. In order to get the potential at point A, you have to know the direction of the conventional current. Mwelekeo wa umeme unapita wapi? Ukianzia huku, ukisema ukichanganya, if now you make a mistake, a common mistake, then you say the direction of the current is just moving from this way going this way. You are definitely wrong and you cannot get the correct answer. Now the direction of the conventional current, we say the current leaves from the positive terminal and enters the negative terminal. Manake inaanzia huku. Huyu ana lose, huyu ana gain. Because this is losing electron because the current is the rate of flow of electric charges. Now the charges are flowing, electrons are moving. Now electrons are being lost. Because this is the direction of the conventional current. Because sasa, as it is moving from here, ikifika hapa ina draw potential difference hizi hapa. Hizi zinatumika. Katika tisa zinaondoka hizi hapa. Lakini ukianzia huku utakosea kwa sababu utakalculate kwamba hizi hapa zimeondoka na hizi hapa zitaondoka. Kwa utasema hapa ni kitu kingine. Kwa maana yake anapopita kwenda hivi, akifika hapa ana drop hizi hapa. Maana yake zinatumika hizi hapa. Zinaondoka katika ile 9 volt. Now the potential difference at point A means these 2.4 have been used. Now we have left how many volts are there out of 9? And that's why potential difference at point A is equal to voltage across the battery minus voltage across the voltage at point 1, R1. Which now, this is 9 volts minus 2.4. Here it is 60, then 8 plus 2, it is what? Now the potential difference at point A is equal to 6.6 volt. Lakini kama ingetokea nimeambiwa at point B here. If it would happen that now I'm talking about point B, it is here. Maana yake kwamba tayari ninge-drop huyu hapa na ninge-drop huyu hapa. Zingebaki ngapi? Eventually ingebaki hii hapa tu. The potential difference at point A is equal to the total voltage across the battery minus the used voltage, that is the potential difference at point R1. Tayari unapata ya hapa. The answer is equal to 6.6 volts. In the circuit shown below, the battery has voltage V is equal to 9. R1 is equal to 4 ohms. R2 is equal to 5 ohms. R3 is equal to 6 ohms. These resistors are connected in parallel. Now what is common? What is common here? Voltage. Now voltage at R1 and voltage at R2 and voltage at R3 are equal. Now this here is 9 volts. Also here is 9 volts. Also here is 9 volts. Also here is 9 volts. Now the question is, what is the total resistance of the circuit? Now R total 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now 1 over R total is equal now to 1 over R1. R1 is what? 4 plus 1 over R2, 5 plus 1 over R3, 6. Now the LCM of 4, 5 and 6 is what? 60. 60. Now it's equal now, the LCM is 60. 60 divided by 4, 15 times this one? 15 plus this divided by this one? 12. Then plus this divided by this one? 10. Now it's equal to what? It is 37. Now 37 over 60. Now 1 over R total is equal to 37 over 60. Is it so? Now inverting. Now R total is equal now to 60 over 37. Inverse of 1 over R total. Now 60 over 37 is equal to what? 1.60 ohm. Now the total resistance of the circuit is equal to 1.6 ohm. Now we are through about the first question. Now the second question, what is the total current flows in the circuit? Remember from Ohm's law. From Ohm's law is equal to IR. Is this so? Now we are looking for the current. Current is equal to V over voltage over resistance. Now voltage is equal to what? 9. Resistance is equal to total resistance, which is equal to 1.6. Now is equal to, now the total current passing through the circuit is equal to 5.6 ampere. Now what is the current flows through each resistor? I've said what is common. When resistors are connected in parallel, what is common? Voltage is common. Now for R1 is equal to 4 ohms. Now voltage is equal to 9. We are looking for the current, which is equal to V over R. Now V over R, it is 9 over R. R is equal to what? To 4. 9 over 4 is equal to what? 2.25. Now that is the ampere. This is the current through the resistor 1, which are 34 ohms. Now R2 is equal to what? 5 ohm. Now V is common, 9 volt. Now current is equal to V over R. Now voltage is equal to 9 over 5, which is equal to what? 1.8 ampere. Now current at what? At resistor 2. That one. Now for resistance is equal to what? 60 ohm. Now voltage is common, 9 volts. Now current is equal to V over R. Now which is equal to 9 over 6. Which is equal now to what? 1.5 ampere. Now current at resistor 3 is equal to, if now you want to know, remember yesterday we talked much about Kirchhoff's law. The sum of the current entering the junction must be equal to the sum of the current leaving the junction. Now the current at, we have I1, we have I2, we have I3. If you sum them, make sure that you have got what we are talking about here. 5.6. Is it true? Now let us prove. We have 2.25. We have 1.8. Then we have 1.5. Now it is what? 5. Then it is what? 15. Then it is what? 4, 5. Now it's equal to 5.55. If now you approximate, you get 5.6 ampere. Now, the sum of the current entering the junction should be equal to the sum of the current leaving the junction. That is Kirchhoff's law. And that's why now we have got, after summing them, we have got the sum of the current entering the junction is equal to the sum of the current leaving the junction. Now, 5.6 is equal to 5.6. Is it so? Have I made myself clear? There's the question. You've been asked to calculate, determine the current reading on the ammeter in the circuit below. You calculate the total resistance of the circuits. Kwa unaanza na hizi hapo na ziminya inakuwa moja. Then na hii hapo na binya inakuwa moja. Then una finalize zote zinakuwa kwenye series. Now the first set of parallel and the second set of parallel resistors. Now from here you have total. The first step is this one. The first step you have 1 over the total is equal to 1 over 24 plus 1 over 8 plus 1 over 12. From 1 over the total, hapo utapata the first set ambao utapata 12 over 48. Now 1 over the total is equal to 1 over 4. Then our total is equal to 4 ohm. This is the first set. Now the second set, you have 1 over R total, which is equal to 1 over 1 plus 1 over 2 plus 1 over 3. Now it is 1 over 60 plus 1 over 3 plus 1 over 6. Now 1 over total is equal now to 12 over 18. Now it is equal to 2 over 3. Now 1 over R total is equal to 2 over 3. Now R total is equal to 3 over 2. Now R total is equal to 1.5 ohm. After now you have done that case, now you have this one. This is the 9 volt. Now here you have ammeter. Then this one, here now you have 20 ohm. Now here you have collected all this one to form 1.5. Now here you have 1.5 ohm. And also this you have corrected them to form 4 ohm. Then here you have 15. Now these are in the series. Now the total resistance, the R total is equal now to R1 plus R2 plus R3 plus R4. Now R1 is equal to 15 plus R2 4 plus R3, which is equal to 1.5 plus 20. Now it is 19, 39, then it is 40.5. Is it so? Now R total is equal to 40.5. This is the total resistance for the circuit. Now after I've got the total resistance of the circuit, now the question is to find out the current. Now the current is equal to V over R total. Now voltage is equal to 9 over 40.5. Now current is equal to 0.22 ampere. Now the reading of the ammeter, is 0.22. Now the current is obtained is equal now to 0.22 ampere or 0.2. The same applies because if you approximate that number, it becomes 2. Now the task here was to combine the parallel resistors, and here to combine the parallel resistors. Kwa hivyo ni kuzikusanya hizi hapa na hizi hapo unazikusanya, alafu then zinazalisha kitu ambacho ni series. Kisha tena unakusanya, unatumia na volt ya hapa, kama unatumia Ohm's law, you get what you need. So it is something very important for you to understand. In series combination, If now you talk about series combination, what is common? Current is common at all points. But when you talk about parallel connection, what is common? Voltage or potential difference is common. That is what's going to happen. Hope now you have understood. See you next time.